In the previous videos, so far we have seen how to create a directed homogeneous graph and how to create a bidirected graph. Okay, so now let's try to understand the data types of these tensors in DGL graphs. So we have already created a directed graph above, so which is storing in the graph object. Okay, so if I just print the graph, you can see, so this is the schema. So we have 5 nodes and 8 edges. Okay, so this is the graph I'm referring. Okay, so this is the directed graph I'm referring, so which is stored in this graph object. Okay, so now let's see what is the id type, okay, of this graph. So I'll just type graph.idtype. So it will return what are the types of tensors that this graph is using. Okay, so in DGL it can either be 32-bit tensors or 64-bit tensors. By default, all the tensors in DGL are of 64-bit tensors. Okay, 64-bit integer tensors. Okay, so what do I mean by this 32-bit and 64-bit? So if we have 32-bit integers, then we can represent 2 power 32 numbers. Okay, that is the numbers ranging from 0 to 2 power 32 minus 1. Okay, so let's say we have the number of nodes or number of edges in our graph exceeding this number. Let's say the number of nodes or edges in our graph are greater than 2 power 32. Then we can go with the 64-bit integers. Okay, but by default it comes with the 64-bit integers, but it's always good to change these data types accordingly, according to the number of nodes and edges that we have in our graph. Okay, and what is 2 power 32? Let's just quickly see how big this number is. So if we see 2 power 32, so 1 2 3 4 5 6 7 8 9, so it's like 4.3 billion. It's close to 4.3 billion. So using the 32-bit tensors, 32-bit integer tensors, we can represent 4.3 billion IDs. That is 4.3 billion nodes or edges, right? In case in our graph, if the number of nodes or edges exceeds this number, then we can go with the 64-bit tensors. Okay, so now the next question is, so how can we change this type? Okay, so we already have the graph type as int64. So now we can actually change this. So let's say I'll do something like graph.int. Okay, and let's say I'll store this graph as 32. Okay, it's a 32-bit okay, 32-bit integer tensor graph. So now I'll try to print the graph 32 id type. Okay, id type. So it's just running. So you can see earlier this is the graph I had where the id type is int64, but now I converted that into int32. Okay, let's say if you wanted to convert this back to int64, that is also pretty straightforward. Let's say I use a new graph object within 64. So you can use, I'm taking the 32-bit graph, that is graph 32, and I'm using long function. Okay, so when you print the id type of this graph, so now we can see, so again it is giving us torch.int64. Okay, so if you have a 32-bit integer, then you can represent the IDs from 0 to 2 power 32 minus 1. If we have the 64-bit integers, then we can represent the IDs from 0 to 2 power 64 minus 1. Okay, and also it would be good to use the relevant tensors. That I mean, if your graph don't have many number of nodes or edges, then it's good to go with the 32-bit integers because they are very fast. And if you really require the 64-bit integers, then you can obviously convert from one type of integers to other type of integers. That's very straightforward using these two methods, graph.int and graph.long. Okay, thanks.